So in 11.2, we've already done adding, subtracting, and multiplying. And the last thing we have to cover is dividing. So before we even start talking about dividing, we need to talk about fractions, because that's all dividing really is fractions. And the first thing I need to remind you of, or well, the first one is a reminder, the second one is a new one. There are two things that are not allowed in the denominator of a fraction. The first we already know, we're not allowed to have a denominator of 0. That's what makes a fraction undefined. The second is that we're not allowed to have a radical in the denominator. When you have a square root or a radical in the denominator, you have some steps you have to take to get rid of it. Those steps are known as rationalizing the denominator. It's right here. This process of rationalizing the denominator is how we're going to get a radical, and it could be a square root or it could be a cubed root, out of the denominator. How do we do that? And the first thing we're going to do is we're going to make sure that this radical is simplified. So, is it simplified? If it is, then your next step is to multiply by 1. Now, it doesn't make much sense to multiply by 1 in the form of 1. We have to multiply by 1 in a little bit of a sneaky way. Instead of multiplying by 1 that way, we need to multiply by 1. Remember, I said these are just fraction problems, right? So what's another way to write 1 as a fraction? Something over itself, right? Anything. 2 over 2, 3 over 3, x over x. All of those things simplify to be 1. Well, now we don't want to simplify, we want to complicate. So when we complicate it, we just simply take whatever that radical is, whatever it is we're trying to get rid of, and as long as it's just a single, it's not a sum or a difference, because those have different rules, we can multiply by 1 like this. So root 5 over root 5 is just 1. And remember, multiplying by 1 doesn't change its value. It's just going to change its shape. So we do multiply across the top, outside times outsides, inside times insides. So 2 times the square root of 5 over, we're going to do, it's our notes, so we're going to do it the long way this time. And maybe for the first few, you'll want to do the long way. But after a while, you'll start to see the pattern. Square root of 5 times square root of 5 is the square root of 25. In the numerator, 2 root 5. Can't simplify that any further. But the square root of 25 we can certainly simplify, because we're trying to get this square root out of the denominator. And the square root of 25 is 5. And this is my simplified fraction. Would you please try this first row? No, just number 1. Try number 1 all on your own. Come back and check your work. Hopefully you did just fine on that first problem. I want to point out to you one little piece that for someone who's not starting to see the shortcut that could happen, I want to point out to you that we could have also written this denominator. I wrote the square root of 49, but I could have also written 7 times 7. Instead of writing it as 49, I could have written it as 7 squared, because by definition that's what that is. And a square root undoes something squared, so that I could end up with a 7. Let's look at number 2, because there's just one little trick I want to talk about with number 2. When we look at a whole entire fraction that's been put underneath a radical, remember that we can split it into 2 pieces. And we should always simplify those numbers before we even try to rationalize the denominator. So simplify means take square roots and make anything that's a perfect square come out of the square root. Rationalize means you're not allowed to have a radical or a square root in the denominator. So we need to multiply by 1, but we're going to make it a hidden 1, or an unsimplified 1. And hopefully you're starting to see that shortcut. The numerator is 1 times square root 5. Not much of a shortcut there. But the square root of 5 times the square root of 5 is going to always be the square root of 25. And the square root of 25 is always going to be 5. So hopefully you're getting to a point where you can just simply do that one. Now problem number 3 is a very important problem. It's one of those ones that you could probably just accept that you have to memorize. You're going to see this so often over the next few years that it's just one of those ones that if you see 1 over square root 2, you could do all the work, same stuff that we've been doing. Square root 2 over square root 2 to get root 2 over 2. But in all honesty, you're going to do that one so many times that you can go ahead and memorize that. All right, so we talked about ones that had just a square root. I'm going to do a whole separate video for how to do ones that have a sum or a difference or a binomial in the denominator. So come back, take a peek at that next video.